In the next video, we are going to look at radical expressions, and we're going to talk about multiplying, dividing radical expressions, and rationalizing. We're also going to talk a little bit about conjugates and what those do for us when we are dividing or rationalizing an expression. So there are some rules, of course, for multiplying radical expressions, and it can be expressed this way. You're going to multiply the inside times the inside and the outside times the outside. And you need to write that down because that's really what you need to remember. So when I have two radicals, which I have right here, I have 2 square root of 5 times 4 square root of 6. Then I'm going to multiply the 2 times the 4, and that's going to be 8. And then I'm going to multiply the 5 times the 6, which is 30. And that's it. That's what you do. Now, the only time that this would cause a problem, like say for instance I wanted to multiply that again times 2 square root of 2, right, is that I would have 8 times 2 is 16, and I could say the square root of 60, but if you'll recall, which of course I could, and then that's going to also factor 3, 2, 2, 5, right? So a 2 will come out, and that'll be 32, and then the 3 and the 5 stay in, so that would be 15. So you might have to simplify it in the end. So you don't have to have just square roots, you can have cube roots. So once again, the outside times outside, inside times inside rule applies. So I'm going to do 3 times 2, which is 6, and then on the inside, cube root, I'm going to have 16 times 4 times a squared. So I'm just going to combine everything, right? Well, if you'll remember, 16 is just 4 times 4, and that's a group. So the 6 stays, the 4 now comes out, and then I have 1, 2, 3, I have a to the third. So this is going to be 24 a to the third. Now, if you want to multiply something that looks like it's in like FOIL, the rule still applies. Outside times outside, inside times inside. It's just that we're going to do these, have to do these 4 times. So we have that, and so I have 3 times 2, so that's 6 square root of 3. So remember, outside times outside, that's an outside number. And then if I do this one, that's inside numbers. So this would be minus 2 square root of 9. I'm going to leave it just like that, even though I know, but you can simplify it. I'm going to do this. The 3 multiplies with the 3, so that's going to be 9 square root of 5. And then here, I'm going to have plus 3, not plus, minus, right, because it's 3 times negative 1, so negative 3, and then the inside is the square root of 15, which is 3 times 5, and that doesn't reduce. So I do have this, right? This is 2 times 3, because the square root of 9 is 3. So I end up with 6 square root of 3 minus 6 plus 9 square root of 5 minus 3 square root of 15. And none of those combine because they don't have, we're back to adding and subtracting, right? None of those combine. And so we're done. Simplifying and rationalizing using the quotient property. Remember, if you will, that this is the same thing as y, the square root of y to the 8th over the square root of x to the 7th. So let's simplify each one, right? Y to the 4th, because I take groups of 2, y to the 4th, and then down here I'm going to take x to the 3rd, square root of x. Now it says rationalize, and what rationalize means is that I don't want to have, or I choose not to have, a square root or radical in the denominator. And the easiest way to rationalize is to just multiply by a form of 1. Remember that anything over itself is just 1. So I'm just multiplying this whole thing by 1. When I do that, I end up with y to the 4th square root of x on the top. Remember, outside times outside. And then on the inside, on the bottom, I have x to the 3rd times x, the square root of x squared, which is x, and that's x to the 4th. And you're done. Okay? Now, simplifying a cube root is a little bit different. So remember that we have groups of 3. So I'm going to rewrite this. I'm going to write cube root of 2 over the cube root of 3 times x. All right? So in order to get that denominator not to have a cube root, I'm going to have to multiply it so that when you multiply those denominators together, you end up with groups of 3. So think about this. You have 1, 2, 3s, so I need another one. That would be 3 3s if I multiplied it together. I have 1x, so I need 2 more. So that when I do multiply it, I'm going to end up with 3x. No cube root, just 3x. All right, so remember it's a form of 1. So whatever I multiply times on the denominator, I have to do on the numerator. Okay? And remember the rule, inside times inside. So on the top, I'm going to end up with 6 x squared. And on the bottom, I'm going to end up with the cube root of 3 times 3 times 3 times x times x times x, which is 3x. So this will be the cube root of 6x squared over 3x, and you're done. So here's an interesting thing. We can rationalize an expression that has 2 things in the denominator. It has 2 radicals, 2 different radicals in the denominator. So remember that rationalizing just means that we're going to remove the radicals from the denominator. You can also rationalize the numerator, and there are certain situations where that might be necessary, but let's do this first. So the easiest thing to do when you're trying to rationalize a denominator is you want to use something that's called a conjugate. So for instance, a conjugate, if you had x plus 3, its conjugate would be x minus 3. If you have, like this one, the square root of 5 plus square root of 2, then your conjugate would be minus square root of 2. And so once again, you're doing this times a form of 1. So really, this whole thing is just something over itself. It's just 1. All right, so let me erase this and get it out of the way. Because these can be a little bit long and tricky, because now what you have is you have 2 terms times 2 terms. So the top part, remember, is outside times outside, inside times inside. So you have this one, you have 2 square root of 10, and this 2 times the square root of 4. And then we have this one, so this is plus 2 square root of 25, and this one, which is negative 2 square root of 10. Okay, so you notice then that on the top, and I'm just working with the top right now, I have 2 square root of 10 minus 2 square root of 10. And then this is 2, so this is minus 4, this is 5, plus 10. So on the top, I end up with 6. Now, on the bottom, I have the square root of 25 minus the square root of 10 plus the square root of 10 minus the square root of 4. And so I end up with 5. These cancel, minus 4, which is negative 1, which is 6. So I hope you took good notes, and we're going to work with these more in class, and so it's going to take some practice, but I really think you're going to do well at them. So I'll see you in class.